Hello, everybody. Let's take a look at example 11 right here. Bailey invests $2,000 in a bank that pays interest at a rate of 4.5% per annum, compounded monthly here. Okay, so part A says sketch a graph to model how much Bailey has in the bank after X years. Okay, so we need an equation for this. And so I brought up the class kick from this topic of interest with different compounding periods. And this was our equation right here. The future value, which in our case will be y, is equal to the present value. And wait, what was the present value of this? $2,000. So $2,000 times 1 plus our interest was 4.5 divided by, okay, k is the compounding frequency, and I believe this one is monthly, so it'll be k is 12. So 12 times 100, which is going to be 1200, and then all to the power of k times n. N is our number of years, which in our case is x, so it'll be k times x. So if you put all those things in, you'll get this equation right here. 2,000 times 1 plus 4.5 all over 1,200. That's 12 for the compounding frequency and 100. So 12 times 100 is 1,200, all to the 12 times x, which is the number of years. So if you put this into your Casio, you can get a graph of this, which can help you sketch it. So if you go to your Casio and go to graph, y is equal to 2,000 times, what is that, 1.00375, all to the 12 times x. Remember, we got to use the x button right here to make that real. Okay, we press enter, we press draw, and we say, where's the graph? And then we remember that V window is something that we have to do. We have to kind of alter the viewing window here. So shift V window. All right. So X is the number of years. We don't really care about negative years in this investment. So we'll just put around -2 just to have a little bit on the negative side here. And let's say, I mean, this could be invested for 50 years. I don't know. We'll put 50 in there. And Y min will be, well, our our starting investment is 2,000, so our max should be pretty big, probably like 5 or 6,000. It could grow. I'll put 6,000 right there, and once we do that, we can press draw, and yeah, we see this. And sometimes I like to just do trace so I can quickly kind of see what some values are. So like if I were to sketch this, I would say, all right, at 0 we are at $2,000, and I don't know, at round 2 we're at 2,200. Round 5 we're at 2,500. And at around 9 years we're at 3,000. And we can make a sketch here. At 12 years we're at 3,433, and so on. So we can use that to sketch right here. The next question here is deduce whether an exponential model is a reasonable choice to model how much she has in the bank. Well, I think so, because interest is like a compounding interest is an exponential thing. We're multiplying by the same number every single time to calculate how much. That 1.00375, that's our common ratio here. So yeah, I'd say it's a good choice for this model. And then C, calculate how much money Bailey has in the bank after 4 years. Let's go back to our Casio. Let's remember our shift G solve skills right here. And if you click on this arrow to get the other options, you'll get the Y calculate and the X calculate. I think for this problem, we want to calculate how much money, which is our Y value, after 4 years, which is our X value. So we'll do Y calculate. All right, enter X value, 4 years. It says 2393, so $2,393.63. Is that what they got? $2,393.63. Yes. Okay. And then part D says calculate how long it will take for her to have $3,000 in the bank. That to me seems like another G solve possibility, but instead of calculating for how much money, we're calculating for how long it will take. So we'll do an X calculate here. We'll enter the Y value of, what was it? $3,000. $3,000. And we see it'll take 9.03 years. 9.03 years, yes. So after 10 years, she will have $3,000 in the bank here. And that's how you can kind of use your Casio and your finance skills to model this. Thank you, everybody.